So, welcome to another lecture. In this lecture, we'll be doing questions from IGCSE 0620 chemistry subject. I've taken past year questions, mainly from 2025 papers, Redox Reactions. Let's start. So, the first question, initially I'll be taking few questions regarding the oxidizing agents and reducing agents, because this is one of the hit topics in IGCSE. So let's look at the first question. Also, another thing that I wanted to share was that all the questions where they have been taken from, you will see this in small font. You will see the year also where the question has been taken from throughout this lecture. So the first question is: ethanol is wound with acidified aqueous potassium manganate solution. Which row describes the type of reaction of the ethanol and color change observed in the reaction mixture? So now, what you need to, there are few things that you need to cram regarding IGCSE reducing and oxidizing agents. So potassium magnate and potassium dichromate, they act as the oxidizing agents. They are the oft repeated oxidizing agents, and potassium iodide would be the reducing agent. I have made a detailed video also regarding this topic. You can have a look at the end of this lecture if you are not very comfortable regarding the oxidizing and reducing agents. So always remember, coming back to the question, always remember when you are looking at aqueous potassium magnate solution, you need to understand that potassium magnate would be acting as a oxidizing agent. So the color change that it will be undergoing would be from purple to colorless. This is something that you need to cram about potassium magnate. And if you look at the reaction, so we are given, I'm going up in bit of detail in this question. So ethanol, acidified potassium magnate is acting as an oxidizing agent. So C2H5OH first converts into CH3CHO. So it first converts into aldehyde. Then, because I've written the complete reaction, because here the KMnO₄ is still there, still acting as an oxidizing agent. So actually the final product would be acetic acid, finally gets reduced to acid. And if you understand about oxidation number also, what you need to understand is that in KMnO₄, the oxidation number of manganese changes from +7 to +2. So that is why there is a color change. So I've tried to put a lot of concepts in this particular question so that you understand, because independent questions based on these concepts can also be asked in the MCQs. So in this example, there is a oxidation which is taking place. Which row describes the type of reaction of the ethanol? So for ethanol, oxidation is taking place. Color change observed in the reaction mixture. The color change would be from purple to colorless. So I hope this is clear. Similar question I want to take, I'll skip these questions, I'll take these in a while. Similar question. I'm taking three similar questions where the oxidizing agent and reducing agents, potassium magnate, potassium dichromate have been taken. Potassium iodide has been taken. So second question, aqueous iron sulfate is added to acidified potassium magnate. Now whenever I see potassium magnate, I understand that it would be acting as an oxidizing agent. The purple color of the potassium magnate disappears. So potassium magnate has done its work as an oxidizing agent and the purple color has disappeared. The second question, the second part of the question, aqueous potassium iodide. Now, aqueous potassium iodide, as I've told you before, potassium iodide acts as a reducing agent. So, potassium iodide is added to acidified potassium dichromate. potassium dichromate, you should remember that potassium dichromate is an oxidizing agent. So this is a reducing agent, this is an oxidizing agent. A dark brown solution forms. Now remember that potassium dichromate, the color change of potassium dichromate would be something like from orange to green. And the color change of potassium iodide will go from colorless to red brown. So finally, there is a mixture of green and red brown, and that is why they have mentioned this as a dark brown solution forms. I hope you are getting the question. I'm going in a bit detail because I want you to understand the concept of oxidizing agent and reducing agents, because there would at least be one question based on this concept. And one of these oxidizing or reducing agents. Which row describes the role of iron sulfate and potassium dichromate in these reactions? Okay. Now the first thing is that I'll use this to mention this in detail. So oxidizing agent, whenever we use an oxidizing agent, it is used as a test for reducing agent. Whenever we use oxidizing agent, we use it as a test for reducing agent. But whenever we use the reducing agent, it is a test for a oxidizing agent. So in this question, you need to understand that for the test of this oxidizing agent, iron 2 sulfate would be acting as a reducing agent. I hope this makes sense. And so we are sure about the iron 2 sulfate. Iron 2 sulfate is acting as a reducing agent. For potassium dichromate, it has met a reducing agent. So reducing agent is used for oxidizing agent. So here potassium dichromate is oxidizing agent. My point is, while discussing this question, as you would have understood that whenever we see potassium magnate, we should understand this acts as an oxidizing agent. Whenever we see acidified potassium dichromate, we should understand it is an oxidizing agent. Whenever we see aqueous potassium iodide, we should understand that this is a reducing agent. So these three are one of the hit examples. These are the oft asked questions in the IGCSE paper. So very important. So the answer now, after detailed discussion, potassium dichromate is acting as an oxidizing agent, and in the first, the iron 2 sulfate is acting as a reducing agent. Hope this is clear. Okay, and let's look at the next question. It's a pretty interesting question, especially because they have considered oxidation reduction in terms of loss of electron, gain of electrons, loss and gain of oxygen. So it's a pretty lot of concepts are being used. So let's go through each of the concept one by one. So the question, which statement about the reactants in redox reaction is correct? So it's a redox reaction and they are asking us about the statements. So the first is oxidizing agent donates electron and a reducing agent accepts electron. So let's understand this. See, oxidizing agent helps in oxidation. How does it help in oxidation? It helps in oxidation by gaining electron. So always remember, oxidizing agent gains electron. A reducing agent helps in reduction. How does it help in reduction? It helps in reduction by losing electrons. So that is why oxidizing agent donates electron. It is incorrect. Reducing agent accepts electron. That is incorrect. So this choice is incorrect. Second is correct, but let's skip this and try to understand what's wrong with the option C and D. When oxidation number of one element increases, a different element gains oxygen. So what is oxidation? The oxidation happens to an entity when the oxidation number of that entity increases. How will the oxidation number of an entity increase? The oxidation number of an entity will increase once it loses electrons. So for example, you look at this example. So let us assume that there is an entity X plus 3. Now the oxidation number is increases from +3 to +4. But how will the oxidation number increase? It will increase by loss of electrons. So remember that oxidation is loss of electrons. That is the first thing that you need to remember. There is another thing. See, in terms of oxygen, oxidation happens when there is a gain of oxygen. Loss of electron, gain of oxygen. Remember that. And what is reduction? In terms of oxidation number, reduction is when the oxidation number decreases. But how will the oxidation number decrease? The oxidation number will decrease once there is a gain of electrons. So for example, again the example of X plus 3. So this plus 3 oxidation number has to decrease to +2. How will it decrease? By gaining electron. So reduction is basically gain of electrons. So gain of electron, in our case, gain of electron also implies loss of oxygen. So reduction in terms of oxygen is loss of oxygen. Oxidation in terms of oxygen is gain of oxygen. So this is something that you need to get familiar with. And that is why I said that this is an interesting question. So let's look at the C option. When the oxidation number of one element increases, okay, oxidation number is increasing. A different element gains oxygen. No, if the oxidation number of the element is increasing, the oxygen will gain oxygen. So that is why this option is incorrect. When the oxidation number of one element increases, a different element loses electron. No, when the oxidation number of one element increases, the same element will lose electrons. So that is why this option is also incorrect. And the final option, which is the correct option, is when one element gains electrons, the oxidation number of a different element increases. Of course, because when one element is gaining electron, it will be undergoing reduction. And the oxidation, so this whosoever gains electron will be undergoing reduction, and the other entity would be going oxidation, and that is why the other entity's oxidation number would be increasing. So I hope this makes sense. For few of you, this might be confusing, but it is good to understand oxidation reduction both in terms of oxidation number, in terms of loss of and gain of electrons, in terms of gain and loss of oxygen. So it helps. Let's move to the next question. Next question: which equations show the underlying species acting as a reducing agent? See, as we have been discussing, so reducing agent helps in reduction, but itself gets oxidized. So the entity which is undergoing oxidation is the reducing agent. So let's see. Fe plus CSO4 gives FeSO4 plus Cu. Now, if we look closely here, so Fe has an oxidation number of 0. Here the oxidation number is +2. Here the oxidation number is +2. So here the oxidation number is increasing. So that is why Fe, because it is going oxidation and the oxidation number is increasing, that is another thing that you need to understand, that the entity which is undergoing oxidation, the oxidation number will increase. So Fe increases from 0 to +2. So that is why here the Fe acts as a reducing agent. In this case, Fe plus 2, Fe plus 3. So oxidation number increases, and that is why it is going oxidation, and that is why it is a reducing agent. So at times it gets a bit confusing, but the more you practice, the more you will understand. If we look at the other, so the answer is actually C, 2 and 3. But if we look at, let's look at 1 and 4 also. So Fe2O3, here the oxidation number of iron is +3. Here it is 0. So oxidation number is decreasing. So here reduction is taking place. So here this entity, this species is actually the let me write it here. The oxidation number is decreasing, and therefore it is acting as an oxidizing agent, not a reducing agent. And if I look at here, Fe would have oxidation number of +2, and here again it is +2. So here there is no change in the oxidation number. If you are not very comfortable with oxidation number, I will put a link of the oxidation number lecture below in the comment section. Next question. Domain is shown. Which row identifies the oxidizing agent and reducing agent? So just to understand again, oxidizing agent itself gets reduced. Reduction. So reduction is the decrease in oxidation number. Always remember that the oxidizing agent will have a decrease in the oxidation number. Reducing agent itself gets oxidized. So reducing agent, the oxidation number increases. So oxidation number decreases for oxidizing agent and oxidation number increases for reducing agent. So let's look at here. Fe +2 gets converted into Fe +3. The oxidation number is increasing. So oxidation number is reducing, is increasing. Fe +2 to +3, oxidation number is increasing. So here FeSO4 is acting as a reducing agent, If we look here, bromine is getting converted into from oxidation number 0 to -1. The oxidation number is decreasing. So bromine here is acting as a oxidizing agent. Hope it is making sense, but of course you should be very clear about the rules of oxidation number. As I've told you before, I'll put the another lecture below where you can understand the rules of oxidation number. Let's move to the next question. Equation represents a redox reaction. From here, the oxidation number 0 is converted to +3. Aluminium changes from 0 to +3. And here, the oxidation number of iron changes from +3 to 0. And the question is, what is the change in the oxidation number of iron? So oxidation number of iron changes from +3 to 0. So this would be the correct answer. This is a simple question. You shouldn't find it very difficult. Next question. Ammonia is converted into nitric acid in a two-step process. Ammonia, oxygen passed over catalyst. The first part was to balance the equation. I have balanced the equation already. Find the oxidation number of nitrogen. So in NH3, the oxidation number of nitrogen would be -3. Why? NH3 metal is hydrogen is bonded with a non-metal, so it will have a oxidation number of +1. So that is why if we assume oxidation number of nitrogen to be X, so X +3 would be 0 and X would be -3. And they are asking about the oxidation number of nitrogen in NO. So here oxygen is -2, so nitrogen would be +2. Again, this is a simple question, 3-number question, simple question. Then the next is define oxidation in terms of oxidation number. Define oxidation in terms of oxidation number. So this is the definition that we should understand. We should be, if we don't understand, we should be able to cram. So in terms of oxidation number, oxidation is the process when elements' oxidation number increases, signifying a loss of electrons. Because oxidation is loss of electrons and making that element the reducing agent. So you can write it here, the definition of oxidation in terms of oxidation number, or you can write simply oxidation in terms of oxidation number. Whenever the oxidation number increases, it is oxidation. Next question is a compound containing chromium. The negative ion in is the Cr₂. The chromate is the negative ion. State the sum of the oxidation number in chromate. So this is the oxidation number. The charge over it is the oxidation number. This is the oxidation number. Okay. The oxidation number of each O in chromate ion is -2. Determine the oxidation number of each chromium in and show you are working. So, if I take Cr₂O₇ -2, so if I assume the oxidation number of chromium to be X, so the equation that I'll find is 2X minus 14 would be equal to -2, and if I calculate X, the value of X would be +6. As I've told you earlier, I have made a lecture on oxidation number. You can have a look at the comment section if you want to refer it, if you are not very clear about the oxidation numbers. Sulfuric acid reacts with carbon. The equation is shown. Give the oxidation number of carbon elemental form, so it will be 0. And in carbon dioxide, oxygen would be CO2. Oxygen would be -2, so X would be equal to 4. It would be equal to 4. Fairly simple question. Fairly simple question, and for 2 marks. Next question. Nitrogen monoxide, carbon monoxide are both removed from exhaust gases of car by a catalytic converter. We know that. So, catalytic converters are used in car to reduce pollution. This statement shows carbon monoxide and nitrogen monoxide, carbon monoxide removed by a catalytic converter. See, because the monoxides are more poisonous. So, here the reaction which will be taking place is that the nitrogen monoxide would be this is the reaction which takes place. By using the catalytic converter, it is converted to nitrogen. So, if we look here, the monoxide is getting converted into nitrogen. We are removing oxygen. So, carbon monoxide is reduced. And if we look at the second reaction, so nitrogen monoxide is getting reduced to nitrogen. And in the second case, carbon monoxide reacts with the oxygen in the gas and is converted into CO2. So here oxygen is being added. So that is why carbon monoxide being oxidized. So hope this makes clear. Because one way of describing redox reaction is that if oxygen is being removed, then it is reduction. And if oxygen is being added, it is oxidation. This is the classical definition. Let's move to the next question. Is found in a core of manganese. Manganese can be extracted from using aluminium as a reducing agent. Define the term reducing agent. So I have written the definition. Reducing agent or reductant is a substance that donates electron to form in a redox reaction, causing species to be reduced. We have discussed this in detail before. So this is the definition that you can refer. Complete the symbol by inserting formula of the missing product and balancing. So this was a balancing, not part of the redox reaction, but still I have taken this here. Let's move to the next question. And the final question, aluminium is extracted from aluminium oxide by electrolysis, ironing half is given, which row describes oxidation number. So aluminium +3 is getting converted into 0. So the change in oxidation number of aluminium, the oxidation number is decreasing. And the type, because the oxidation number is decreasing, so the type of reaction would be reduction. Hope this makes sense and hope. So let's look at oxidizing and reducing agents. This is a topic that usually students find confusing. Let's look at it. So the first is, let me define the oxidizing agent. An oxidizing agent is something which helps in oxidation. A reducing agent is something which helps in reduction. That is the first, a very common sense approach to the topic. So oxidation agent will help in oxidation. A reducing agent will help in reduction. So that is the first point. The second point is oxidation agent, if it is helping in reduction, in oxidizing agent, if it is helping in oxidation, we understand that oxidation is loss of electrons. We use the harmonic oil. So oxidation is loss of electrons. So oxidizing agent, when it helps in oxidation. How will it help in oxidation? It will help in oxidation by accepting the electrons. I'll repeat. Oxidizing agent helps in oxidation. Oxidation is loss of electrons. The oxidizing agent helps in oxidation by accepting the electrons, And when it accepts the electron, it itself gets reduced. So remember, oxidizing agent will get reduced. Oxidizing agent will itself gets reduced. At times this gets confusing. So the best examples of oxidizing agents are KMnO₄ and potassium dichromate. So as I have told you that oxidizing agent will themselves get reduced. That is, they will undergo reduction. They will go reduction in their oxidation number. So if you see potassium magnate, the Mn has an oxidation state of +7. And initially it has an oxidation state of +7, and when it gets reduced, the oxidation state becomes a +2. So oxidizing agent, which is KMnO₄, which is potassium magnate, when it gets reduced, the oxidation number changes from +7 to +2. The second important oxidizing agent is potassium dichromate, K₂Cr₂O₇. Now here, the oxidation number of chromate changes from +6 to +3. So the oxidation number decreases. And because it is an oxidizing agent, it will get reduced. Its oxidation number will reduce. Oxidizing agent helps in oxidation, but it itself gets reduced. So, these are the sequence. This is the sequence of events that you can remember. Another interesting thing about these oxidizing agents, potassium permanganate and potassium dichromate, is that there is a color change. So that is why the things become far more interesting. So potassium dichromate changes from purple to colorless. And potassium dichromate changes from orange to green. Now, please remember that in IGCSE syllabus 0620 chemistry, this is an important topic. Questions are asked almost in every board paper on either the oxidizing agent or the reducing agent. This is for many years questions are asked. So you should be very clear about this. Excel would be very useful, especially for IGCSE students or 0620 chemistry students. So you need to remember the color change also. For potassium permanganate, the color changes from purple to colorless when they are behaving like an oxidizing agent. For potassium dichromate, the color changes from orange to green when they are behaving like an oxidizing agent. Now, another way in which the question is formed is that the oxidizing agent help as a test for reducing agent, and oxidizing agent help as a test for reducing agents. I'll come to reducing agents in a while. I just want to show you the color change because the color change is also very important. So first look at potassium magnate. So for example, if you see this photograph, potassium permanganate, potassium magnate 7 as unknown liquid, the purple color is fading, so the liquid must contain a reducing agent. So for potassium magnate, the color change will be the MnO₄ will change into Mn+2. If you understand oxidation number, then you will understand that +7 is changing into +2. If you have confusion regarding oxidation number, I have another lecture. You can have a look at that. I'll put the link in the comment section. So this is the color change of potassium magnate. The second color change that we discussed was of potassium dichromate. In potassium dichromate, the color changes from orange to green. And another way in which the question can be asked is, potassium dichromate Oxidizing agent, this is one of the very important equations where the alcohol changes into aldehyde, because here the potassium dichromate is acting as an oxidizing agent, and the color change is from orange to green. So this is regarding the, and if you see the oxidation number of Cr, it changes from 6 to 3. So this is regarding the oxidizing agents. Now let's come to the, if you have understood the concept of oxidizing agent, then the concept of reducing agent will also make sense. So what is a reducing agent? A reducing agent is something which will help in reduction. It will help in reduction. What is reduction? We use the same logic. What is reduction? So the mnemonic that we use is RIG. Reduction is gain of electrons. So basically, if you look this very logically, the reducing agent is helping in reduction. Reduction is gain of electrons. So how will it help in reduction? When there is a reduction taking place, there is a gain of electron taking place, then the reducing agent would be the one who will be giving the electrons, so that reduction can take place. I hope you are getting the drift. So basically what I'm trying to tell you is that you can take a very commonsensical approach towards these definitions. So reducing agent will help in reduction by giving electrons. And because it is giving electrons, it itself will get oxidized. It itself will get oxidized. Here also one of the very important IGCSE reducing agent is potassium iodide. It's a reducing agent where the iodide oxidation number changes from -1 to 0. So it will get oxidation. It will get oxidized. The oxidation number will change, will increase -1 to 0. And as I've told you, it will the reducing agent will itself get oxidized by losing electrons, by giving electrons. And the color change again, colorless, from colorless to red brown, from colorless to red brown. Now here also it is used as a, because it's a reducing agent. Here the inverse is true. A reducing agent would be used as a test for oxidizing agent. Would be used as a test for oxidizing agent. So let's look at the color change also. For potassium iodide also, so if you see the color, this shows the red-brown color you get when potassium iodide is oxidized by an oxidizing agent. So hope this makes sense now. And the approach that I have taken is a very commonsensical approach, that we understand the meaning of the word, so that oxidizing agent and reducing agent make sense. And it always helps. For example, in IGCSE, these three are the important compounds that we need to understand, because questions are asked. And as per the respective board that you are in, you can refer to the the oxidizing agents and the reducing agents which are mentioned.